to kick off complex numbers here, let's consider the quadratic equation x squared equals -1. Okay? Using what we've been talking about, right? How do you solve an equation like this? What should we do to both sides? Square root, right? You have x squared, you want to square root both sides. Okay? And so we have x equals, and now if we go back to like our very, basic understanding of the, the foundational understanding of what x squared equals -1, what that means, we want to think of numbers that when you square it, right, give you -1. So we could try and think of like a positive number here, okay, but any positive number, if you square it, its answer will be what? Positive times a positive is positive, right? But we need a -1. Okay, so if we don't use positive numbers, we could try using a negative number here, right? Let's try like, we could take a negative number. If we squared a negative number, though, a negative times a negative would give us a positive, which is not what we have here. We need to be negative. So, positive numbers don't work. Negative numbers don't work. We can try 0, right? That's only a non-positive or negative number there. 0 squared, though, is not going to give us -1. And so, we don't have an answer in our real number system. So like the majority of the time, right, when we're doing math, we work in the real number system. That's, all the numbers we typically work with. But it fails us here. We create a situation where it doesn't work anymore, right? And so we end up with this thing that we don't know what it's equal to. And so we create a new number system, expanding what we currently have. And we say that this is the number I, okay? Which is known as the imaginary unit. Okay. And so now we have the set of real numbers, and then outside that set of real numbers, okay, is the imaginary numbers, all the numbers that have I associated with them. I need square roots of negative numbers. Okay. And then if you take the imaginary numbers, all the numbers with I, and the real numbers, okay, two separate, right, mutually exclusive from each other, they do not overlap, real and imaginary. You put them together, you call those the complex numbers, right? Complex numbers include all the reals and all the imaginaries with them. And then also like stuff that's like real and imaginary together. Okay? So, you should have seen this back in Algebra 1, but it's been a while, I get it. So, we'll go from there. So some things with I, right? When we have, for example, that, so some properties here. Okay. If R is greater than 0, then the square root of -R will equal the square root of -1 times the square root of R, right? Using that same property we talked about before, where we have a product, we break it up into, we can break up a square root over a product. And then instead of writing the square root of -1, we just said, right, the square root of -1 is I. So we'll just write I times the square root of R. Okay, so that'll be, one way that we simplify those square roots of negative numbers. And then one other property here, okay, let me see how I want to do this. So taking our answer there, I times the square root of R, and squaring it, okay, is equal to I squared times the square root of R squared. Okay, let's do the easy one first, right? What is the square root of R squared? What does that simplify to be? R. Just R, that's right. Got a bunch of pirates in here. And then I squared, what does that simplify to be? Well, so if I is the square root of -1, and if you square a square root, what will be left over from this? Just -1. Okay? So we get just -R. Okay. So I squared is equal to -1. Right? I squared is -1. All right. Questions on any of that? All right, so let's have you guys try one here. So solve for x using square roots. Okay. I know I didn't show you an example yet, but get as far as you can. Get as far as you feel comfortable or confident. All right? Go as far as you feel comfortable or confident. Ms. Witt, I don't feel comfortable right now. So, okay. Try to do a little more than that. Try and simplify as much as you can. So what you would do, what we're going to do when you see what I show you here, is that since anytime you take the square root of a negative number, any negative number, you can always factor negative 1 out. There is your I, and then you simplify the positive square root as the moment. Get as far as you feel comfortable. Maybe you just get x by itself, right? But then you're like not sure how to put the square root of that negative number you get. Okay, so that's fine. So don't forget, if it was a negative 48, we divided by 2, it would be a negative. Yeah, exactly. Because they are, kind of like, it's like you would have the numbers there. That's a pretty good. The only thing I would further add is a plus or minus since we're in the equation setting. I didn't show that earlier, Mike, because we weren't technically in this is not technically an equation, it's just. Okay, good. So far, so good. Yeah, remember your plus or minus in front. That's no, go to that point. That's important. Good. So don't square root until you isolate the x squared first. In other words, you see that x squared, get that by itself first, and then square root. Okay, so you want to fix that, and then we'll get to that. Good. What I can always say is put a plus or minus one. Now we're in the equation setting. Yeah. Okay, so what would you normally do? Yes. Right, we'll get to that point. So get that point and we'll go beyond it, okay? No, that's right. Why did you divide by 2? So the only the x being squared here, if that was if it was 2x being squared, you'd see parentheses. So you start off by dividing the house by 2. Then so you have 2 times x squared, right? Only the x being squared. So that 2 is a 2. It's not 2 squared, it's like 2. So it's divided by 4 on both sides. Yeah. So you still have your x squared. So x squared equals and then whatever the answer of that is. All right. Looks like people made some progress here, so let's get to where many of us got to. So we subtract 11 on both sides, we get negative 48. We divide both sides by 2, we get negative 24. Okay? And at this point, right, hopefully we all got to this point. Any questions up to this point? If not, any questions up to this point? Okay. Now, what should be our next step? Square root, right? Square root. You get the x squared by itself, so you square root. Okay? So I should have x equals. Now, I'm in the equation setting, so I should also throw that plus or minus in front here. Okay? The square root of negative 24, I'm going to take the time here and just simplify. So, it's a negative, which means we're dealing with what kind of number here? So, yep, negatives. And it's going to be imaginary too, right? Imaginary. That's what I was looking for there. Imaginary. Yes. So, how can we fix this? Where's the negative 1? Well, we're going to factor out a negative 1 and make this not root negative 24, but root negative 1 times root 24. Okay, break it up into the imaginary negative 1 and the real part, 24 there. Okay? Real as in real number, right? Square root of negative 1, we cannot simplify that, right? So this just becomes I. Square root of 24. Can we simplify the square root of 24? Yeah. Yes. What perfect square can we divide out of 24? Yeah, so it'd be, so root 4 and root 6. Okay? So the negative 1, we take care of the negative 24 by pulling out a negative 1, make it I. Then we have a positive root 24, and we just simplify that like we normally would. So what is the square root of 4? 2, so you get 2I root 6. Can I divide 6 by any more perfect squares? No, right? We can only divide it by 1. It wouldn't really simplify. So this is what we can put right down there. There is our answer. There is our answer. So positive 2I root 6, negative 2I root 6. Questions on any of that? Slade?
If you waited to make pretty much I,
Mm-hmm.
and you waited until you got to 4 and 6.
Yeah. You can do that.
Like 2 I's.
Yep, 2I, and then root 6. Oh, I see. You're saying like if you took the negative 24, well, if we broke up the negative 24, then one of these numbers would be negative, one would be positive, though. So you wouldn't have 2 I's, you'd still only have 1 I. The I would be with whichever one, you'd have a negative number there. Is that what you were asking? So you're like, what if we did from here, Mr. Widmeyer, what if we made that root negative 4 times root 6, like that? Yeah. So then this, okay, would be... you'd break up that negative 4 into root negative 1, root positive 4. This would then be your I, there would be your 2, and then there's your root 6. So 2I root 6 there as well. Does that answer your question now? And so, yeah, you don't have to simplify it exactly like how I do, but I'm just trying to give you, a way that I feel like is, pretty well organized and stuff. So. All right. Other questions? All right. So, yeah, that's how we're going to be simplifying those square roots. I don't think... of course, I'll give you more practice here later on in class, but I just want to give you, there's how the I is going to show up. All right, but I want to also talk about some other things here too. So when we introduce those, like I said, the imaginary numbers, right, we have then this bigger now set of numbers that we're talking about. Okay, so a complex number is any number that can be written in the form A plus BI. A and B are real numbers. Okay. The A part is referred to as the real part, okay, of the complex number. And anyone want to guess what the BI part is referred to as? Yeah, the imaginary part, right. Why do you think it's referred to as the imaginary part? Because it has the I, and A does not have the I, so it's the real part. Okay, that's it. That's it. So the complex number system marries the real and imaginaries together. Okay. So the number 3. Okay. The number 3, it's a complex number. It's when the A value is 3 and the B value would be 0 because it doesn't have any imaginary there. So the number 3, right, would be A is 3, B would be 0, and that would create, that means it's a complex number as well. 3 is a complex number, okay? 2I, right, so 2I root 6. This is an imaginary number, right, because it's got the I there with it, all right? And so the A value of this would be 0, right? There's no real part to this. But this would mark about that 2. Yeah, but the 2 is a part of the product with the I, right? So the 2 and the root 6 would both be B. So plus or minus 2 root 6, that'd be the B, and then the I part right there. So this is all an imaginary part right here. There's no like A number that we're adding or subtracting in front. That would be a real number. Okay. So that makes our complex numbers. Okay. So with this new complex number system, we can of course add, subtract, multiply, and divide as well. So let me look at those. So arithmetic. Let me do adding and subtracting first. Okay, and this is so intuitive. You guys will probably be just fine with this. Okay. And I'm going to just get examples with adding and subtracting. I'm not even going to do any sort of abstract stuff here. So I don't know. I'll do 8 minus I plus 5 plus 4I. Okay, so 2 complex numbers, right? And we'll also subtract 2. 7 minus 6I minus 3 minus 6I. Okay, so I'm actually going to give you guys, take 30 seconds, okay, think about what you would do here, okay? 30 seconds. And if you want to go ahead and do it, go ahead and do it. If you really feel confident, you know what, I know how to do this, I'm going to do this. All right, I'm pretty sure it's this, do it, okay? But think about what you should do here. What do you think makes the most sense for you to do here? We're going to add these two things together, or we're going to subtract. Subtraction might be a little bit trickier, but at least think about the add. Okay, so you have 30 seconds. Think about it. If it looks similar to stuff we've done before, it is. It is similar to stuff. All right, so Matthew, what did you think of when you tried to add these two things together here?
I wasn't sure.
So didn't get anywhere then with it? Or you had an idea or anything? No? Okay, fair enough. All right, how about Dylan? Do you have any idea about what to do here? No? Okay. Well, let's go to Sienna. Any idea about what to do?
I don't know if it's right.
Okay.
I got 13 plus 3i.
13 plus 3i. Now, how in the heck did you get that?
I don't remember. 8 plus 5 is 13. And then I just did minus negative I plus 4i. Just do 3i.
That's exactly right. This is combining like terms. It is combining like terms, okay? That is exactly it. Combine like terms. Combine the real parts, 8 and the 5, add together, make 13. Combine the imaginary parts, negative I and 4i, combine together, make 3i. This is like adding polynomials. That's all there is to it. Okay, that's all. So then when we subtract, I prefer to change subtraction to addition. You don't have to, okay? If you feel comfortable subtracting a 3 and subtracting a negative 6i, that's your choice. You can do that. I'm going to make it adding. So we'll make this add the opposites. Okay, so change that minus quantity to plus the opposites. Okay, so same strategy as Sienna said. 7 combines with a negative 3 to make a positive 4. Negative 6 combines with a positive 6i to make nothing. So 0i if you like, or you can just say 4. So that's crazy. We started with 2 complex numbers. Add them together, and we got a real answer. No imaginary, real. Okay? Complex to real. Here we've had 2 complex numbers we add together, and we ended up with a complex number. I mean, understand, it's real, it's also complex. So, I mean, this is also a complex number because the I is 0 there. So you could give that as an answer, too, if you wanted to. This is fine as well. Or this one is good. That's all there is to it. Okay?
If I is -1, couldn't you solve it?
So be careful. I is not -1. I is the square root of -1, right? So yeah, I squared is -1. I is just square root of -1. So does that answer your question? Then you see how you can't like combine it there and stuff. All right, so that's adding and subtracting. I didn't want to spend too much time on that just because it's like, hey, it's adding and subtracting. Any questions though before I move on? All right. All right. Now let's talk about multiplying. And then we'll talk about dividing. I'll do a simpler one and then the trickier one, the multiplication stuff here. Okay. But again, yeah, I'm going to do it. I'm going to do it. So I'll write them both out here. So again, I'm going to give you guys the opportunity to kind of like, go out on your own here. Okay. You maybe talked about adding, subtracting complex numbers in Algebra 1. I don't think you probably talked about multiplying complex numbers in Algebra 1. But, I think you can do it. So, again, do what you think is intuitive here, okay? Do what comes natural to you when it comes to multiplying these out and see what you can come up with on your own without me forcing you to. Come on, check. You want to, quietly ask me. Yeah, that's a 7i plus 7i. There we go. Well, so here you're adding, right? Can you add a -6 with an I? Are they like terms? No, so we can't combine. So we have to leave them separate. There you go. I like what you're drawing into. That's good. Yes. So be careful that it's 4i. So at the end, yes. So -24. There you go. Well, there's 4 times what's the number in front of this I? Well, you can see a little bit more. So 4 times what's the number in front of this I? 1, right? 1. So 4 times 1 is 4, and then I times I would give you. Right. So when we're adding now, since you have a square. So let's go back to this. This is right. Okay. This is I squared. Can you add these two things together? No, because they're different. They're not like terms, right? But you do have ways to simplify I squared. Well, let's go back to our. So we saw an I squared earlier. What did that equal? Right. Well, because we also squared this too.
So just -1.
Right. So here you go. 4 times I squared. I squared was just. So it's 4 times -1. Something in front of parentheses. What do you do when you have something in front of parentheses? Yeah, distributed, right? You have addition. So, same thing here. It's like a binomial, use a binomial. You could put 4 over there or something like that. No, because you're adding. That's the difference. We're adding two things together, so you only combine like terms. Here, because we are multiplying, right? You see they're next to each other, so it's different. That's the difference, right? Okay, let's see how we did here. Okay, so let's go to Tim. Tim, were you able to come up with something here for letter A? Okay. Walk us through what you did. Sorry if you don't mind. Don't just give the answer. What did you do for this?
I distributed the 4i.
Yeah, this is distribution property here, folks. Okay, we have addition in the parentheses, something in front of parentheses. So yeah, when you distribute the 4i to the negative 6, what do we get? Negative 24i. Very good. And then 4i times the I? 4i squared. Very good. Are these like terms, Tim? Can I combine these two things together?
No.
They both have an I. Why can't I?
1 squared.
One's I squared, one is just I, right? This is just like if we had x and x squared here. Except we can simplify I squared. Did you simplify the x squared?
Yeah.
What is I squared the same as?
And -1.
Yes. So, and again, I'm writing this more explicitly. You can, skip this part if you wanted to there. But so in other words, it's negative 4 minus 24i. Okay. If you have it reversed and you have negative 24i minus 4, that's fine. Just understand that the standard way of writing a complex number is the real part first, then the imaginary part. But that is the final answer. Yes. I squared. Remember, folks, I by itself, I is equal to the square root of negative 1. Right? So if you have I squared, that's the square root of negative 1 squared. When you square a square root, it cancels out. Just negative 1. Okay. Questions on any of that? That's the idea. No questions? No questions? All right. Letter B. Let's see what we did here. Paige, were you able to come up with something here for letter B?
I distributed, like I split it out.
Yeah, exactly. This is a binomial. This is a binomial. So we're going to multiply it out if you would. So yeah, you can use FOIL here. If you want to do like the arches, we do like 9 times negative 4, 9 times 7i, negative 2i times negative 4, negative 2i times 7i. You can do that. Just make sure that every term here multiplies with every term here. Okay, that's the idea. So yeah, what do we get when you do that, Paige?
Got negative 27 plus 63i plus 8i minus 14i.
Okay, so 9 times negative 4 would give us negative 36. But then go ahead. Sorry, you said then 9 times 7i, you got 63i, you said?
Yeah.
Okay.
8i.
And then plus 8i, that's right. And then minus,
14i.
yeah, so everything else is perfect. Great job. Okay, everything else. Okay. Is that it? Is that the best we can do, Paige, or is there more we can do?
Then you can put it on
Yeah, so what are our like terms we have right now?
71i.
Okay, yeah, the 63i and 8i together make a 71i. But we also know that I squared, from what Tim told us earlier, right, from what we saw, what we know about I squared would become just a what? Negative 1. And so we're going to really have negative 36 plus 71i plus 14, right? Because the I squared is negative 1 times negative 14 equals positive 14. And then we can combine that with the negative 36. So we get negative 22, yep, plus 71i. And there's our final answer. Okay. Now, this all works on your calculator too, believe it or not. Okay, Mr. Wood, are you kidding me? You finished all that work? Yeah, I did, because you're going to have to be able to do this without a calculator. So, for example, 9 minus 2, to access I, it's second and then the decimal button. You can see it if I do an extreme close-up here. There we go. Look at that little guy right there, just above the decimal point. Okay, the I, there it is. So you press second decimal, 9 minus 2i, okay, close parenthesis, open parenthesis, negative 4 plus 7i. Okay, look, I just hit enter. Oh my gosh, there's the answer. Look at that. Okay. Please don't plan on doing this for all of your homework though, because you need to be able to do this without a calculator, right? But you can use your calculator to help you check yourself. Okay. So there it is. All right.
Yeah, for B, why is it plus 14 when you do the minus 14 I squared, but it's minus 4 when you for A?
So, sure. So let's start with this, right? So negative 2i times a positive 7i, you're okay with it being negative 14i squared. Okay. I squared is equal to negative 1. So in other words, when I have a negative 14i squared, that's negative 14 times a negative 1.
So it'd be positive.
So it'd be positive 14 plus 14.
Then how is it for A? How is it minus 4?
Well, because we start with a positive 4i squared, became a negative 1, now negative 4. So here we start with negative 14i squared, became positive. Here we start with a positive 4i squared, became negative.
Oh, so it just.
I'm going to flip the sign. The I squared over the other. Flip the sign. If you want to take it that way. Yeah. Okay. Question.
I don't understand why, like, you remove the I squared when you take negative 1.
From here to here.
Yeah.
So I jumped a step here. So negative 14i squared, right? That's negative 14 times negative 1 because that's what I squared is. And then negative 14 times negative 1. There's your positive 14 that it becomes. Okay. So if you need to, obviously feel free to take that step, write that step in for yourself when you're doing it. Okay. All right. We've done addition. We've done subtraction. We've done multiplication and simplification, but we haven't done division. So here we go. Division. The favorite. The best. Okay. The best one. Dividing complex numbers. Okay, and our goal here again is to write in standard form. And standard form is that complex number form. Okay. So can I just do 7 divided by 1 and 5 divided by negative 4 here? No. Because it's never that easy, Mr. Whitmire. Right? And that would be bad math. Because when you divide, okay, and you have subtraction or addition in your denominator, right, that means we can't break up that denominator. Okay? So we can't say 7 divided by 1, 5 divided by negative 4, 5 divided by negative 4i, because it's got that subtraction there. That kind of joins these two things together. So what could I write? I could write 7 over 1 minus 4i. So I could say this, plus 5i over 1 minus 4i. But actually, it's going to make things more complicated than we need to. But this is true. So you can break up a numerator over addition subtraction. But we can't break up a denominator over addition subtraction. It's not quite right. But we're not going to use this. We're going to go back to the original here. Now, when you guys remember talking about square roots, right? One of the things you had to keep an eye out for is we didn't want to have square roots where? If we had a fraction, we don't want square roots where? In the denominator. Do we have a square root in the denominator here?
Yeah.
So we don't see one, but what does I really mean? Square root of negative 1, so we do have a square root in the denominator here. But we have a way to deal with square root in the denominator. Right? What do we multiply by? Starts with a C. Conjugate. We're going to multiply by the conjugate here. Okay? So what would the conjugate of 1 minus 4i be? 1 plus 4i. Exactly right. Okay? Multiply by conjugate. Okay? That's it. So that old skill that we had, a couple days back, we're going to use it again. So 1 plus 4i over 1 plus 4i. Okay? And you can see now why we practiced multiplying complex numbers first. Because when we go to divide and simplify, using division and stuff like that, we're going to end up doing some multiplication. Okay? So 7 plus 5i times 1 plus 4i Okay, so the set is it's FOIL, right? So it's going to be 7 times the 1, 7 times the 4i, 5i times the 1, 5i times the 4i. So 7 times 1 is 7. 7 times 4i, 28i. 5i times 1, 5i. 5i times 4i, 20i squared. All over. Okay. Same thing here. We'll multiply. I have to FOIL it out. I'll do this one in red, maybe so. So 1 times 1, 1 times 4i. 4i times 1, 4i times 4i. 1 times 1 is 1. 1 times 4i is 4i. Negative 4i times 1 is negative 4i. Negative 4i times 4i, negative 16i squared. Right? Negative 4i times 4i, negative 16i squared. Okay. Questions up to this point? I'll pause right here to make sure we're all okay. Questions so far? I'm not going to give you a million things, right? But you should be able to do 1 or 2. And we're not done yet. So what can I do with my numerator? What can we do here? Simplifying it.
Combine like term.
Combine like terms, yeah, Jordan. So what's like in this numerator here?
The 16. Oh,
Sorry, the numerator.
Yeah, my bad.
That's okay.
It's the 28i plus the 5i.
Which would give us
33.
33i. And let's go ahead and deal with that I squared. I squared, we remember, is the same thing as negative 1. So I'm going to change that 20i squared to be 20 times negative 1 over. Okay. How about that denominator? What can we do with the denominator? What simplifies here? The 4i and the negative 4i, what happens? They cancel. They're gone. Okay? And so we'll have 1 minus 16. And again, I'm going to change that I squared to be negative 1. Okay? So far, so good? Okay. So then that's a negative 20. Negative 20, right? Plus 7. So that's negative 13 plus 33i over... Negative 16 times negative 1, positive 16, and then plus the 1 there makes us 17. Okay. And technically this is not in standard form yet. I need to break it up thusly. And then this is true appropriate standard form right there. Okay, where we have the real part separated from the imaginary part by addition or subtraction. Okay. So there's a line. Question? Yep.
Where did the 20?
Where the 20 go? Like, so 7 and then negative 20 together made that negative 13. Okay. Yeah. Any other questions? No. Okay. Well, then I'm going to get you guys started on your assignment here, okay? We have a good 15 minutes, a little less than 15 minutes, but still, you got a good amount of time here to get started. I'm going to post this on Schoology, so you'll, I haven't posted it just yet. It's in the green book again, but I'll get that for you. So let's hear. Starting on page 279, we'll have you numbers. Nine, 11, 15, 18, Mm-hmm. 22. 25. 28. 31. And if you want some like extra weird ones, I'm going to say 24. That's there. Yeah. Push to 24. There you go. Okay. 24 is a bit of a different one. That's why I wanted to maybe give it to you at the end there.